Thanks a lot. So today I'm going to talk to you about how you can hopefully curate your EFIS data set correctly and quickly. And this title promises maybe a bit too much because disclaimer, as Alessio said, I think there's currently no perfect solution to this. And it's really something that's a lot of people are working on, including us. And I'll do my best to
Sorry,
present the current options and what I think are the best solutions to this problem.
just mentioning your screen is not full screen. Is that on purpose?
Um, let's leave it like this. So with the advent of Neuropixel probes, manually curating, going through your groups of spikes or units, clusters, and assigning them labels based on what you think, if they're actually a nice, well-isolated unit, or if the spikes come from maybe are just noise or something else, is becoming intractable in most cases. And this is a good problem to have. You know, we have so much data that actually we can't really manually curate all of it. And it's even more true now with the advent of more and more chronic implants, which I believe a few people are going to talk to you about. You really can't do this over, for instance, 30 days, and especially not in a reliable way if you actually want to track neurons across all of these days. And so we're going to talk about the current approaches to curation and focus on approaches that are not manual curation. So the historical approach is what I just mentioned, manual curation. So you curate with Phi, or for instance, a spike interface GUI that Alessia mentioned, your data. And there are other approaches there are several quality metric based packages that can handle different aspects of quality control. And there are also more ML based approaches, which can sometimes be a mix of quality metrics and then ML training, which I think also Alessia also mentioned unit refine, and Annie will talk about unit match. Um, and currently, this is really an unsolved problem. So there are many people, including us, that are working on this open problem. The bottleneck is really having good benchmarks, and for that, good ground truth data sets, not only to solve curation, but upstream to evaluate like spike sorters and even processing pipelines. And I think this is kind of a big ongoing field right now. So I'm going to focus on our approach today, which is Bombcell, which I believe has a pretty good shot at least partially solving the curation problem. And I'm not really going to talk about, especially in 15 minutes, about manual curation with Phi or Spike interface. And actually, other people have already done this, I think, better than I could. So I'm just pointing you to some resources. This is a great YouTube video by Nick Steinmetz, and you can scan this QR code to have an overview of how to actually use Phi. And there's also great resources by the Spike interface team about their GUI. So I'm just going to go first over the general conceptual framework of Bombcell, and then I'll talk about some of the individual quality metrics, and after that, talk about how you can actually decide on quality metrics and thresholds, and finally talk about which tool kind of to choose for which problem. So Bombcell is a quality metric package, and we have a series of quality metrics to sort out units into 4 categories automatically: noise, non-somatic, multi-unit, or good. And that was kind of our design principle, that it should really be automatic, and there should be these 4 categories. And how this actually works is for each metric in each unit, you have a value. And this is the hypothetical distribution for one metric of all the values for each unit. And you have a threshold, and there are standard preset thresholds, but users can also then remove entirely a metric or adjust the thresholds really easily. The idea is to really have something that is very interpretable, that's easy and quick to run. You can reuse data sets for different purposes, and it's very easy to share what you've done and let people know what you've let people know what you've done and understand what other people have done, because you can just publish the thresholds of these metrics, and then you know exactly how to reproduce what they've done in the paper. So this is one of the big kind of design principles of Bombcell, of making it very interpretable and easy to use. And another principle that we thought was really important is to have a lot of visualization tools. As you use more automated approaches, you can less and less actually look at your data and even sometimes at the output of these approaches. And we believe it's really important to still keep an understanding of your data and what's actually going on behind the scenes and how the quality metrics are working. So we have an automatic generation of summary output plots. These are in tiny, and I'll go over them later in bigger, but basically we'll show you the template waveforms of units that are removed or kept, and you can have a quick overview of how well Bombcell is working. In that case, we'll show you which quality metrics are actually removing how many units and how they interact. So our two quality metrics kind of removing the same units. And we'll also show you the distribution of quality metrics for each quality metric and each unit having one value, so all the histograms, and how those lead to classification of units into the different categories. So these are just very general plots that give you a very quick overview of what's going on, how many units are being removed, and can kind of give you an idea of potentially how things are working. And we also have a built-in GUI. So again, I'll go over more detail over this later, but essentially you can look at each unit and flip through them and look at, for instance, the template waveforms, the raw waveforms, and on top of all this, we'll show you the quality metrics that Bombcell has computed and kind of how Bombcell has computed the metrics. So it'll give you an idea of how well Bombcell is actually performing for your data. And we'll show you all of these, but also on the side for each unit where it lies in the distribution, which can give you a sense of if you want to actually fine-tune some things. On top of this, you can add some manual labels, and we'll go over this a bit more later. And finally, Bombcell integrates with Phi. So if you compute quality metrics in Bombcell, they'll then automatically be loaded in Phi's cluster view, which means that it's hopefully easy to assess and kind of interpret results and get intuition, and easy to fine tune. And finally, Bombcell is also the idea is really to have a community toolbox where people contribute. This is just the map of people who have used and contributed to Bombcell. And the idea is to really have a set of thresholds that people publish, and that you can then understand in which circumstance you can use which kinds of thresholds. Okay, so actually I'm seeing that it's already 8 minutes. Well, I'll see. Okay. I'm going to go over just some of the quality metrics in Bombcell, the noise and non-somatic metrics. And I had a longer talk last year where I talked about false positive and false negative metrics. And I'll just link that talk and you can go watch that portion of the talk. So if we talk about noise, noise can occur for many different reasons. For instance, electrical noise, if a lick spout is not grounded, it will result in noise artifacts when the mouse's tongue actually touches the spout. Same for movement. You can have physical movement of the mouse that will cause movement of the brain relative to the probe. And of course, that can lead to erroneous conclusions. So for instance, you could think that a particular unit actually is encoding movement or reward in this case, when actually this is just a noise artifact and you really want to remove this from your analysis. Otherwise, you would have potentially false conclusions. So what are the characteristics of real units as compared to noise artifacts? It's easier to list the properties of good units. So good units have their soma is going to be closer to one specific channel, one recording site on the probe, and that is where the spikes that we see are going to be largest. And further away, spikes will have a smaller amplitude. This is called spatial decay. And we can have a quality metric to really measure exactly this, if the detected spikes are spatially uniform across the probe or actually have a really nice spatial decay. Neurons also should have a neuron-like waveform shape. And what does this mean? It means one well-defined trough and one or two well-defined peaks for most cell types. Some exceptions in cerebellum. And also a particular duration. And so we have quality metrics to measure exactly that. We detect the number of peaks and troughs and check if they actually make sense. We check if the waveform duration also makes sense. If this initial portion is actually flat, this I'm still not entirely sure why, but usually all these quality metrics leave a few noise units, and this one seems to remove the remaining ones. And finally, if actually the size of the trough relative to the size of the repolarization peak actually makes sense. Okay, so since we're already 10 minutes in, I'm going to skip talking about non-somatic quality metrics, but we also have quality metrics to evaluate non-somatic, and finally also to remove and distinguish multi-unit activity from actually good single-unit activity. And for all of these metrics and explanations, I'll point you to last year's video that you can watch. All right, and so now I'm going to talk about how do you actually use Bombcell? How do you evaluate the output? So the first thing you can do for a lot of these quality metrics is just set thresholds based on what you know about your region or regions of interest. So for instance, what are the refractory period windows for the neurons in your regions of interest? What are typical spike durations? And what are typical spike shapes? So for certain cell types, you might have a larger number of peaks, for instance, and troughs, and you might want to adjust that quality metric. So that's a very, very principled way of actually setting threshold based on what you know and should expect. You can also do it based on your assessment of Bombcell's classification. So what I mean by that is looking at what Bombcell's doing and do you actually agree, and should you adjust some of the thresholds so that it better matches how you would have classified these units. And you can do this on a few data sets and then generalize to the others. So Bombcell outputs a few plots. It will show you all the waveforms of units that have been classified as, for instance, noise, and you can see that most of these do indeed look like noise, or more as good units and non-somatic units. And this is a quick way of kind of seeing, in the good unit category, for instance, are there any units that actually look like they're noise, or am I, missing a lot of good units actually that are classified in the noise category? And this would be kind of a pointing you towards you should look more at these metrics and potentially adjust the thresholds. Also with the distribution plots showing you what are the distribution of quality metric values for your units and how are they actually classifying your units into the 4 different categories. This is just a very quick assessment, like for the waveforms, are any quality metrics removing far too many or none at all? This would be an indication that you should look more closely at these metrics and perhaps fine-tune them. And then the best way to actually fine-tune, I think, is really for a few data sets, flip through all the units with the quality metric GUI and actually assess whether Bombcell labels correspond to your manual labels. So you can add manual labels, and then you can automatically compare the manual labels to Bombcell's classification. And Bombcell will suggest which thresholds you can potentially adjust to see if it actually matches what you believe. Okay, and finally, the last way is you can select quality metric thresholds in a very principled way based on a measure of interest. So for instance, if you're very interested in spatial information, this was in the hippocampus, you can evaluate spatial information when including neurons that have different values per particular quality metric, in this case, isolation distance. You can see that it kind of flattens, the spatial information increases until you reach about isolation distance here about 25. So that may be a really natural way and area to actually set your threshold for that particular metric. Okay, and then finally, so this is really ongoing work in progress, but how do we actually know if Bombcell is doing a good job? I think this is something that's really important, is actually properly benchmarking these tools. And we've only just started to do this. But one thing we can look at is when you compare neurons that are recorded in gray matter versus white matter, neurons in white matter, there should be a lot more noise and non-somatic. You shouldn't really have a lot of good units, and this is what we see. So the fraction of good units and of multi-units really decreases. And also if you compare to manual curation, this is just in a few data sets. Bombcell and manual curation seem to mostly agree on what are actually good units. And actually, interestingly, in the cases where they disagree, so here are all the waveforms where Bombcell decided this was actually a good unit. And if you look at them, they mostly seem pretty good to me. And when you look at the units where manual users actually decided these were good units, it seems more variable. So it seems like potentially they are in quite good concordance, and it's just somewhat errors in manual curation, because it is really hard to manually curate your data set and go through so many units. But I think really what will be important going forward is actually having ground truth synthetic data sets and comparing to this to actually properly benchmark. All right, now I'm quickly going to go over basically which tool to choose for which job. So manual curation, as we've talked about, it's slow and you can have potential biases. There's some subjective element to it, but you can look at the data more and build really a good intuition for your data, and you know exactly what you've done. And it can be done more importantly at the spike level, something that really other approaches haven't solved fully well. So what I mean by that is if you have two different units where you believe the spikes actually come from one same neuron, you can merge them. And if you have a unit where you believe there are actually two different groups of spikes in that unit that come from two different neurons, you can also split them. And this is really the main big advantage of manual curation. Quality metrics, so they're just simple quality metrics, which have very simple thresholds. So you might miss some more complex patterns of actually trying to properly classify your neurons into noise versus good, for instance. And they're mostly unit-based for now, especially. So Bombcell doesn't handle any merging or splitting, but there are some approaches that handle merging. However, no approach handles splitting currently. The advantage is, as compared to manual, is really it saves a lot of time. It's very interpretable, and you can use domain knowledge. You can choose thresholds in a principled way. And there are also more ML-based approaches, including unit refine that Alessio talked about, which I think are really great. So these are trained on manual curation, so you can still have some potential implicit bias, but you can identify more complex patterns and potentially do a better job of actually sorting your units and classifying them into these groups. And again, like quality metrics, it really saves a lot of time. So basically, I think there are a lot of tools, and it's not a question of really which is better, but it's a question of using the right tool for your purpose. So here I've tried to summarize all the different approaches, or the main approaches. And also, it's important to note that since I created this, and I've also created Bombcell, this is going to be a slightly biased table, because I created Bombcell with certain principles in mind, which I believe are important. But basically, there are several packages that have quality metrics, and there are other packages that can deal with other things. So, however, so Bombcell really separates, and that's how we designed it, neurons into different categories, such as noise, non-somatic, and we didn't go over this, but you can actually select good time chunks in a recording. And we'll generate output plots, which we believe is really, really important. However, other approaches actually work with lots of different spike sorters and data formats, and Bombcell currently doesn't do this at all, although we're really hoping to integrate Bombcell into Spike Interface, because we think that Spike Interface is really great. There are other approaches that can actually handle merging and tracking of units, which some people will talk about today. And these approaches, obviously Bombcell can't handle this, so you would need to use those for that particular problem. And this is just kind of a global overview of my best attempt at which tool you should use for which job. So for instance, if you're not using KiloSort, you will definitely want to use Spike Interface or something that's been integrated with Spike Interface. Depending on the language you're interested in, you might have different preferences for tools. And if you actually want to look at the paper and see if there's been, rigorous benchmarking been done, some of these approaches have done that. And I believe actually these can really be combined. So for instance, Bombcell and unit match work really well together, and then you can actually have quality metrics and assign labels to these 4 different categories automatically, but you can also merge units or potentially track them over days with unit match, which I believe is really great. And one important thing to note is, again, none of these approaches can actually handle splitting of units. So again, as I said, these approaches are really complementary, and I believe you can use them in conjunctions. You can use quality metrics, be it Bombcell or some other metric, some other package, with unit match or with some other method to actually merge and track cells. You can also combine them with manual curation and use quality metrics as a way to weed out a lot of junk, and then manually curate only the few potential good candidates that are remaining. And I think it will depend really on your use case. So for instance, if you have very few neurons, like a very rare cell type, or you're trying to look at connected pairs, something really insanely rare, you'll probably want to use quality metrics with lax thresholds and then manually curate the rest on the kind of candidate units. If you have lots of neurons and you're really interested in single unit analysis, you'll probably want to use quality metrics with quite strict thresholds. And if you're only interested in population analysis, you can have laxer thresholds and keep more neurons because you're, averaging everything and looking at things at a population level. Okay, and finally, I really want to acknowledge all the wonderful people that have helped with this toolbox, in particular, a lot of people in the Kenneth Harris and Matteo Carandini lab and all the Bombcell community.